Organic farming is a form of agriculture that relies on techniques such as crop rotation, green manure, compost, and biological pest control. Depending on whose definition is used, organic farming uses fertilizers and pesticides if they are considered natural, but it excludes or strictly limits the use of various methods for reasons including sustainability, openness, independence, health, and safety. Organic agricultural methods are internationally regulated and legally enforced by many nations, based in large part on the standards set by the International Federation of Organic Agriculture Movements, an international umbrella organization for organic farming organizations established in 1972. The USDA National Organic Standards Board definition as of April 1995 is OE organic agriculture is an ecological production management system that promotes and enhances biodiversity, biological cycles and soil biological activity. It is based on minimal use of off-farm inputs and on management practices that restore, maintain and enhance ecological harmony. Since 1990 the market for organic food and other products has grown rapidly, reaching $63 billion worldwide in 2012. This demand has driven a similar increase in organically managed farmland which has grown over the years 2001 to 2011 at a compounding rate of 8.9% per annum. As of 2011, approximately 37 million hectares worldwide were farmed organically, representing approximately 0.9% of total world farmland. History. Traditional farming was the original type of agriculture, and has been practiced for thousands of years. Forest gardening, a traditional food production system which dates from prehistoric times, is thought to be the world's oldest and most resilient agroecosystem. Artificial fertilizers had been created during the 18th century, initially with superphosphates and then ammonia-based fertilizers mass-produced using the Haber-Bosch process developed during World War I. These early fertilizers were cheap, powerful, and easy to transport in bulk. Similar advances occurred in chemical pesticides in the 1940s, leading to the decade being referred to as the pesticide era. But these new agricultural techniques, while beneficial in the short term, had serious longer-term side effects such as soil compaction, erosion, and declines in overall soil fertility, along with health concerns about toxic chemicals entering the food supply. Soil biology scientists began in the late 1800s and early 1900s to develop theories on how new advancements in biological science could be used in agriculture as a way to remedy these side effects, while still maintaining higher production. In Central Europe, Rudolf Steiner, whose lectures on agriculture were published in 1925, created biodynamic agriculture, an early version of what we now call organic agriculture. Steiner was motivated by spiritual rather than scientific considerations. In the late 1930s and early 1940s, Sir Albert Howard and his wife Gabrielle Howard, both accomplished botanists, developed organic agriculture. The Howards were influenced by their experiences with traditional farming methods in India, biodynamic, and their formal scientific education. Sir Albert Howard is widely considered to be the father of organic farming, because he was the first to apply scientific knowledge and principles to these various traditional and more natural methods. In the United States, another founder of organic agriculture was J.I. Rodale. In the 1940s he founded both a working organic farm for trials and experimentation, the Rodale Institute, and founded the Rodale Press to teach and advocate organic to the wider public. Further work was done by Lady Eve Balfour in the United Kingdom, and many others across the world. There is some controversy on where the term organic as it applies to agriculture first derived. One side claims term organic agriculture was coined by Lord Northburn, an agriculturalist influenced by Steiner's biodynamic approach, in 1940. This side claims the term as meaning the farm should be viewed as a living organism and stems from Steiner's non-scientific anthroposophy. The second claim is that organic derives from the work of early soil scientists that were developing what was then called humus farming. Thus, in this more scientific view, the use of organic matter to improve the humus content of soils is the basis for the term, and this view was popularized by Howard and Rodale. Since the early 1940s, both camps have tended to merge. increasing environmental awareness in the general population in modern times has transformed the originally supply-driven organic movement to a demand-driven one. Premium prices and some government subsidies attracted farmers. In the developing world, many producers farm according to traditional methods which are comparable to organic farming but are not certified and may or may not include the latest scientific advancements in organic agriculture. In other cases, farmers in the developing world have converted to modern organic methods for economic reasons. Organic farming systems. There are several organic farming systems. Biodynamic farming is a comprehensive approach, with its own international governing body. The do-nothing farming method focuses on a minimum of mechanical cultivation and labor for grain crops. French-intensive and bio-intensive methods are well suited to organic principles. Other examples of techniques are holistic management, permaculture, SRI and no-till farming. Methods. An organic farm, properly speaking, is not one that uses certain methods and substances and avoids others. It is a farm whose structure is formed in imitation of the structure of a natural system that has the integrity, the independence and the benign dependence of an organism. Organic farming methods combine scientific knowledge of ecology and modern technology with traditional farming practices based on naturally occurring biological processes. Organic farming methods are studied in the field of agroecology. While conventional agriculture uses synthetic pesticides and water-soluble synthetically purified fertilizers, organic farmers are restricted by regulations to using natural pesticides and fertilizers. The principal methods of organic farming include crop rotation, green manures and compost, biological pest control, and mechanical cultivation. These measures use the natural environment to enhance agricultural productivity. Legumes are planted to fix nitrogen into the soil, natural insect predators are encouraged, crops are rotated to confuse pests and renew soil, and natural materials such as potassium bicarbonate and mulches are used to control disease and weeds. Hardier plants are generated through plant breeding rather than genetic engineering. While organic is fundamentally different from conventional because of the use of carbon-based fertilizers compared with highly soluble synthetic-based fertilizers and biological pest control instead of synthetic pesticides, organic farming and large-scale conventional farming are not entirely mutually exclusive. Many of the methods developed for organic agriculture have been borrowed by more conventional agriculture. For example, integrated pest management is a multifaceted strategy that uses various organic methods of pest control whenever possible, but in conventional farming could include synthetic pesticides only as a last resort. Crop diversity. Crop diversity is a distinctive characteristic of organic farming. Conventional farming focuses on mass production of one crop in one location, a practice called monoculture. The science of agroecology has revealed the benefits of polyculture, which is often employed in organic farming. Planting a variety of vegetable crops supports a wider range of beneficial insects, soil microorganisms, and other factors that add up to overall farm health. Crop diversity helps environments thrive and protect species from going extinct. Soil management. Organic farming relies heavily on the natural breakdown of organic matter, using techniques like green manure and composting, to replace nutrients taken from the soil by previous crops. This biological process, driven by microorganisms such as mycorrhiza, allows the natural production of nutrients in the soil throughout the growing season, and has been referred to as feeding the soil to feed the plant. Organic farming uses a variety of methods to improve soil fertility, including crop rotation, cover cropping, reduced tillage, and application of compost. By reducing tillage, soil is not inverted and exposed to air. Less carbon is lost to the atmosphere, resulting in more soil organic carbon. This has an added benefit of carbon sequestration, which can reduce greenhouse gases and aid in reversing climate change. Plants need nitrogen, phosphorus, and potassium, as well as micronutrients and symbiotic relationships with fungi and other organisms to flourish, but getting enough nitrogen, and particularly synchronization so that plants get enough nitrogen at the right time, is a challenge for organic farmers. Crop rotation and green manure help to provide nitrogen through legumes which fix nitrogen from the atmosphere through symbiosis with rhizobial bacteria. Intercropping, which is sometimes used for insect and disease control, can also increase soil nutrients, but the competition between the legume and the crop can be problematic and wider spacing between crop rows is required. Crop residues can be plowed back into the soil, and different plants leave different amounts of nitrogen, potentially aiding synchronization. Organic farmers also use animal manure, certain processed fertilizers such as seed meal and various mineral powders such as rock phosphate and green sand, a naturally occurring form of potash which provides potassium. Together these methods help to control erosion. In some cases pH may need to be amended. Natural pH amendments include lime and sulfur, but in the U.S. some compounds such as iron sulfate, aluminum sulfate, magnesium sulfate, and soluble boron products are allowed in organic farming. Mixed farms with both livestock and crops can operate as lay farms, whereby the land gathers fertility through growing nitrogen-fixing forage grasses such as white clover or alfalfa and grows cash crops or cereals when fertility is established. Farms without livestock may find it more difficult to maintain soil fertility, and may rely more on external inputs such as imported manure as well as grain legumes and green manures, although grain legumes may fix limited nitrogen because they are harvested. Horticultural farms growing fruits and vegetables which operate in protected conditions are often even more reliant upon external inputs. Biological research into soil and soil organisms has proven beneficial to organic farming. Varieties of bacteria and fungi break down chemicals, plant matter and animal waste into productive soil nutrients. In turn, they produce benefits of healthier yields and more productive soil for future crops. Fields with less or no manure display significantly lower yields, due to decreased soil microbe community, providing a healthier, more arable soil system. Weed management. Organic weed management promotes weed suppression, rather than weed elimination, by enhancing crop competition and phytotoxic effects on weeds. Organic farmers integrate cultural, biological, mechanical, physical and chemical tactics to manage weeds without synthetic herbicides. Organic standards require rotation of annual crops, meaning that a single crop cannot be grown in the same location without a different, intervening crop. Organic crop rotations frequently include weed-suppressive cover crops and crops with dissimilar life cycles to discourage weeds associated with a particular crop. Research is ongoing to develop organic methods to promote the growth of natural microorganisms that suppress the growth or germination of common weeds. Other cultural practices used to enhance crop competitiveness and reduce weed pressure include selection of competitive crop varieties, high-density planting, tight row spacing, and late planting into warm soil to encourage rapid crop germination. Mechanical and physical weed control practices used on organic farms can be broadly grouped as tillage, turning the soil between crops to incorporate crop residues and soil amendments. Remove existing weed growth and prepare a seed bed for planting. Turning soil after seeding to kill weeds, including cultivation of row crops. Mowing and cutting, removing top growth of weeds. Flame weeding and thermal weeding, using heat to kill weeds. And mulching, blocking weed emergence with organic materials, plastic films, or landscape fabric. Some critics, citing work published in 1997 by David Pimentel of Cornell University, which described an epidemic of topsoil erosion worldwide, have raised concerns that tillage contribute to the erosion epidemic. The FAO and other organizations have advocated a no-till approach to both conventional and organic farming, and point out in particular that crop rotation techniques used in organic farming are excellent no-till approaches. A study published in 2005 by Pimentel and colleagues confirmed that crop rotations and cover cropping typical of organic agriculture reduce soil erosion, pest problems, and pesticide use. Some naturally sourced chemicals are allowed for herbicidal use. These include certain formulations of acetic acid, corn gluten meal, and essential oils. A few selective bioherbicides based on fungal pathogens have also been developed. At this time, However, organic herbicides and bioherbicides play a minor role in the organic weed control toolbox. Weeds can be controlled by grazing. For example, geese have been used successfully to weed a range of organic crops including cotton, strawberries, tobacco, and corn, reviving the practice of keeping cotton patch geese, common in the southern U.S. before the 1950s. Similarly, some rice farmers introduce ducks and fish to wet paddy fields to eat both weeds and insects. Controlling other organisms. Organisms aside from weeds that cause problems on organic farms include arthropods, nematodes, fungi and bacteria. Organic practices include, but are not limited to, encouraging predatory beneficial insects to control pests by serving them nursery plants and/or an alternative habitat, usually in a form of a shelter belt, hedgerow, or beetle bank. Encouraging beneficial microorganisms. Rotating crops to different locations from year to year to interrupt pest reproduction cycles. Planting companion crops and pest-repelling plants that discourage or divert pests. Using row covers to protect crops during pest migration periods. Using biologic pesticides and herbicides, using no-till farming, and no-till farming techniques as false seedbeds, using sanitation to remove pest habitat. Using insect traps to monitor and control insect populations. Using physical barriers, such as row covers. Examples of predatory beneficial insects include minute pirate bugs, big-eyed bugs, and to a lesser extent ladybugs, all of which eat a wide range of pests. Lacewings are also effective, but tend to fly away. Praying mantis tend to move more slowly and eat less heavily. Parasitoid wasps tend to be effective for their selected prey, but like all small insects can be less effective outdoors because the wind controls their movement. Predatory mites are effective for controlling other mites. Naturally derived insecticides allowed for use on organic farms include Bacillus thuringiensis, pyrethrin, spinosad, neem and rotenone. Fewer than 10% of organic farmers use these pesticides regularly. One survey found that only 5.3% of vegetable growers in California use rotenone while 1.7% use pyrethrin. These pesticides are not always more safe or environmentally friendly than synthetic pesticides and can cause harm. The main criterion for organic pesticides is that they are naturally derived, and some naturally derived substances have been controversial. Controversial natural pesticides include rotenone, copper, nicotine sulfate, and pyrethrins. Rotenone and pyrethrin are particularly controversial because they work by attacking the nervous system, like most conventional insecticides. Rotenone is extremely toxic to fish and can induce symptoms resembling Parkinson's disease in mammals. Although pyrethrin is more effective against insects when used with pyperonyl butoxide, organic standards generally do not permit use of the latter substance. Naturally derived fungicides allowed for use on organic farms include the bacteria Bacillus subtilis and Bacillus pumilus, and the fungus Trichoderma hasianum. These are mainly effective for diseases affecting roots. Compost tea contains a mix of beneficial microbes, which may attack or outcompete certain plant pathogens, but variability among formulations and preparation methods may contribute to inconsistent results or even dangerous growth of toxic microbes in compost teas. Some naturally derived pesticides are not allowed for use on organic farms. These include nicotine sulfate, arsenic, and strychnine. Synthetic pesticides allowed for use on organic farms include insecticidal soaps and horticultural oils for insect management. And Bordeaux mixture, copper hydroxide and sodium bicarbonate for managing fungi. Copper sulfate and Bordeaux mixture, approved for organic use in various jurisdictions, can be more environmentally problematic than some synthetic fungicides disallowed in organic farming. Similar concerns apply to copper hydroxide. Repeated application of copper sulfate or copper hydroxide as a fungicide may eventually result in copper accumulation to toxic levels in soil, and admonitions to avoid excessive accumulations of copper in soil appear in various organic standards and elsewhere. Environmental concerns for several kinds of biota arise at average rates of use of such substances for some crops. In the European Union, Where replacement of copper-based fungicides in organic agriculture is a policy priority, research is seeking alternatives for organic production. Livestock. Raising livestock and poultry, for meat, dairy and eggs, is another traditional, farming activity that complements growing. Organic farms attempt to provide animals with natural living conditions and feed. While the USDA does not require any animal welfare requirements be met for a product to be marked as organic, this is a variance from older organic farming practices. Also, horses and cattle used to be a basic farm feature that provided labor, for hauling and plowing, fertility, through recycling of manure, and fuel, in the form of food for farmers and other animals. While today, small growing operations often do not include livestock, domesticated animals are a desirable part of the organic farming equation, especially for true sustainability, the ability of a farm to function as a self-renewing unit. Genetic modification. A key characteristic of organic farming is the rejection of genetically engineered plants and animals. On October 19, 1998, participants at IFOAM's 12th Scientific Conference issued the Mar del Plata Declaration, where more than 600 delegates from over 60 countries voted unanimously to exclude the use of genetically modified organisms in food production and agriculture. Although opposition to the use of any transgenic technologies in organic farming is strong, agricultural researchers Luis Herrera Estrella and Ariel Alvarez Morales continue to advocate integration of transgenic technologies into organic farming as the optimal means to sustainable agriculture, particularly in the developing world, as does author and scientist Pamela Ronald, who views this kind of biotechnology as being consistent with organic principles. Although GMOs are excluded from organic farming, there is concern that the pollen from genetically modified crops is increasingly penetrating organic and heirloom seed stocks, making it difficult, if not impossible, to keep these genomes from entering the organic food supply. Differing regulations among countries limits the availability of GMOs to certain countries, as described in the article on regulation of the release of genetic modified organisms. Standards. Standards regulate production methods and in some cases final output for organic agriculture. Standards may be voluntary or legislated. As early as the 1970s, private associations certified organic producers. In the 1980s, governments began to produce organic production guidelines. In the 1990s, a trend toward legislated standards began, most notably with the 1991 EU eco-regulation developed for European Union, which set standards for 12 countries, and a 1993 UK programme. The EU's programme was followed by a Japanese programme in 2001, and in 2002 the US created the National Organic Programme. As of 2007, over 60 countries regulate organic farming. In 2005, IFOAM created the Principles of Organic Agriculture, an international guideline for certification criteria. Typically, the agencies accredit certification groups rather than individual farms. Organic production materials used in foods are tested independently by the Organic Materials Review Institute. Composting. Under USDA organic standards, manure must be subjected to proper thermophilic composting and allowed to reach a sterilizing temperature. If raw animal manure is used, 120 days must pass before the crop is harvested if the final product comes into direct contact with the soil. For products which do not come into direct contact with soil, 90 days must pass prior to harvest. Economics. The economics of organic farming, a subfield of agricultural economics, encompasses the entire process and effects of organic farming in terms of human society, including social costs, opportunity costs, unintended consequences, information asymmetries, and economies of scale. Although the scope of economics is broad, agricultural economics tends to focus on maximizing yields and efficiency at the farm level. Economics takes an anthropocentric approach to the value of the natural world. Biodiversity, for example, is considered beneficial only to the extent that it is valued by people and increases profits. Some entities such as the European Union subsidize organic farming, in large part because these countries want to account for the externalities of reduced water use, reduced water contamination, reduced soil erosion, reduced carbon emissions, increased biodiversity, and assorted other benefits that result from organic farming. Traditional organic farming is labor and knowledge intensive, whereas conventional farming is capital intensive, requiring more energy and manufactured inputs. Organic farmers in California have cited marketing as their greatest obstacle. Geographic producer distribution. The markets for organic products are strongest in North America and Europe, which as of 2001 are estimated to have $6 and $8 billion respectively of the $20 billion global market. As of 2007, Australasia has 39% of the total organic farmland, including Australia's 1,180,000 hectares, but 97% of this land is sprawling rangeland. US sales are 20x as much. Europe farms 23% of global organic farmland, followed by Latin America with 19%. Asia has 9.5% while North America has 7.2%. Africa has 3%. Besides Australia, the countries with the most organic farmland are Argentina, China, and the United States. Much of Argentina's organic farmland is pasture, like that of Australia. Spain, Germany, Brazil, Uruguay, and the UK follow the United States in the amount of organic land. In the European Union, 3.9% of the total utilised agricultural area was used for organic production in 2005. The countries with the highest proportion of organic land were Austria and Italy, followed by the Czech Republic and Greece. The lowest figures were shown for Malta, Poland and Ireland. In 2009, the proportion of organic land in the EU grew to 4.7%. The countries with highest share of agricultural land were Liechtenstein, Austria and Sweden. 16% of all farmers in Austria produced organically in 2010. By the same year, the proportion of organic land increased to 20% in 2005. 168,000 ha of land in Poland was under organic management. In 2010, 100,000 ha of land were under organic management in Romania, representing 1% of the total utilized agricultural area. 70%-80% of the local organic production, amounting to €100 million in 2010, is exported. The organic products market grew to €50 million in 2010. After the collapse of the Soviet Union in 1991, agricultural inputs that had previously been purchased from Eastern Bloc countries were no longer available in Cuba, and many Cuban farms converted to organic methods out of necessity. Consequently, organic agriculture is a mainstream practice in Cuba, while it remains an alternative practice in most other countries. Although some products called organic in Cuba would not satisfy certification requirements in other countries, Cuba exports organic citrus and citrus juices to EU markets that meet EU organic standards. Cuba's forced conversion to organic methods may position the country to be a global supplier of organic products. Growth. As of 2001, the estimated market value of certified organic products was estimated to be $20 billion. By 2002 this was $23 billion and by 2007 more than $46 billion. By 2012 the market had reached $63 billion worldwide. Europe and North America have experienced strong growth in organic farmland. In the EU it grew by 21% in the period 2005 to 2008. However, this growth has occurred under different conditions. While the European Union has shifted agricultural subsidies to organic farmers due to perceived environmental benefits, the United States has not, continuing to subsidize some but not all traditional commercial crops, such as corn and sugar. As a result of this policy difference, as of 2008 4.1% of European Union farmland was organically managed compared to the 0.6% in the US. As of 2012 the country with the most organic land was Australia, followed by Argentina, and the United States. Productivity. Studies comparing yields have had mixed results. A meta-analysis study published in 2012 suggests farmers should take a hybrid approach to producing enough food for humans while preserving the environment. A study published in 1990 made 205 comparisons. of yields from organic and conventional farming systems, data from 26 crops and 2 animal products, in the form of the ratio of organic to conventional yields, were normally distributed with a mean of 0.91, a standard deviation of 0.24 and a modal value between 0.8 and 0.9. More than one-half of the comparisons of milk production and bean yields had ratios greater than 1.0, that is higher yields from organic than conventional systems. There was no evidence to show that the organic systems had any effect on year-to-year variability in yield, either climate-induced or caused by any transitional or conversion effects. The study also discussed procedural difficulties in comparing the productivity of organic with other farming systems. A U.S. survey published in 2001 analyzed 150 growing seasons of data on grain and soybean crops and concluded that organic yields were 95 to 100% of conventional yields. A study spanning 2 decades was published in 2002 and found a 20% smaller yield from organic farms using 50% less fertilizer, 97% less pesticide, and energy input was 34% to 53% lower. A 2003 study found that during drought years, organic farms can have yields 20 to 40% higher than conventional farms. Organic farms are more profitable in the drier states of the United States, likely due to their superior drought performance. Organic farms survive hurricane damage much better, retaining 20 to 40% more topsoil and smaller economic losses at highly significant levels than their neighbors. A study published in 2005 compared conventional cropping, organic animal-based cropping, and organic legume-based cropping on a test farm at the Rodale Institute over 22 years. The study found that the crop yields for corn and soybeans were similar in the organic animal, organic legume, and conventional farming systems. It also found that significantly less fossil energy was expended to produce corn in the Rodale Institute Euro-1 registered trademark S organic animal and organic legumes systems than in the conventional production system. There was little difference in energy input between the different treatments for producing soybeans. In the organic systems, synthetic fertilizers and pesticides were generally not used. As of 2013, the Rodale study was ongoing and a 30-year anniversary report was published by Rodale in 2012. A 2007 study compiling research from 293 different comparisons into a single study to assess the overall efficiency of the 2 agricultural systems has concluded that organic methods could produce enough food on a global per capita basis to sustain the current human population, and potentially an even larger population, without increasing the agricultural land base. The researchers also found that while in developed countries, organic systems on average produce 92% of the yield produced by conventional agriculture, organic systems produce 80% more than conventional farms in developing countries, because the materials needed for organic farming are more accessible than synthetic farming materials to farmers in some poor countries. This study was strongly contested by another study published in 2008 which stated, and was entitled, "Organic Agriculture Cannot Feed the World," and said that the 2007 came up with a major overestimation of the productivity of OA, because data are misinterpreted and calculations accordingly are erroneous. Another study published in 1999 from the Danish Environmental Protection Agency found that, area for area, organic farms of potatoes, sugar beet and seed grass produce as little as half the output of conventional farming. Michael Pollan, author of The Omnivore's Dilemma, responds to this by pointing out that the average yield of world agriculture is substantially lower than modern sustainable farming yields. Bringing average world yields up to modern organic levels could increase the world's food supply by 50%. Profitability, the decreased cost of synthetic fertilizer and pesticide inputs, along with the higher prices that consumers pay for organic produce, contribute to increased profits. Organic farms have been consistently found to be as or more profitable than conventional farms. Without the price premium, profitability is mixed. Organic production was more profitable in Wisconsin, given price premiums. For markets and supermarkets, organic food is profitable as well, and is generally even sold at significantly higher rates than non-organic food. However, when the buyer compares prices and buys consciously, organic food is not always more expensive for the buyer than non-organic food. For example, in 2000, Philip Reynard made his restaurant to switch to use 85% organic food, without increasing the cost for the clients. In the documentary Architects for Change, he also stated that since 2000, the cost of organic products has come down even more, and at present, it is no longer a problem to attain organic products at a price comparative to products of non-organic agriculture. Energy efficiency. A study of the sustainability of apple production systems showed that in comparing a conventional farming system to an organic method of farming, the organic system in this case is more energy efficient. A more comprehensive study compared efficiency of agriculture for products such as grain, roughage crops, and animal husbandry. While the study did not investigate specific additional requirements of arable land or numbers of farm laborers to produce total yields for organic farming versus conventional farming, leaving open the question of overall capacity of organic farming to meet current and future agricultural needs, it concluded that organic farming had a higher yield per unit of energy over multiple crops and for livestock. However, conventional farming had higher total yield. Conversely, another study noted that organic wheat and corn production was more energy efficient than conventional methods, while organic apple and potato production was less energy efficient than conventional methods. A study done with apple orchards in the state of Washington found that organic orchards found to be at least 7% more energy efficient. Sales and marketing. Most sales are concentrated in developed nations. These products are what economists call credence goods in that they rely on uncertain certification. Interest in organic products dropped between 2006 and 2008, and 42% of Americans polled don't trust organic produce. 69% of Americans claim to occasionally buy organic products, down from 73% in 2005. One theory was that consumers were substituting local produce for organic produce. Distributors. In the United States, 75% of organic farms are smaller than 2.5 hectares. In California, 2% of the farms account for over half of sales. Small farms join together in cooperatives such as Organic Valley, Incorporated, to market their goods more effectively. Most small cooperative distributors have merged or were acquired by large multinationals such as General Mills, Heinz, Conagra, Kellogg, and others. In 1982 there were 28 consumer cooperative distributors, but as of 2007 only 3 remained. This consolidation has raised concerns among consumers and journalists of potential fraud and degradation in standards. Most sell their organic products through subsidiaries, under other labels. Organic foods also can be a niche in developing nations. It would provide more money and a better opportunity to compete internationally with the huge distributors. Organic prices are much more stable than conventional foods, and the small farms can still compete and have similar prices with the much larger farms that usually take all of the profits. Farmers' markets. Price premiums are important for the profitability of small organic farmers. Farmers selling directly to consumers at farmers' markets have continued to achieve these higher returns. In the United States, the number of farmers' markets tripled from 1,755 in 1994 to 5,274 in 2009. Labor and employment. Organic production is more labor-intensive than conventional production. On the one hand, this increased labor cost is one factor that makes organic food more expensive. On the other hand, the increased need for labor may be seen as an employment dividend of organic farming, providing more jobs per unit area than conventional systems. World's food security. In 2007, the United Nations Food and Agriculture Organization said that organic agriculture often leads to higher prices and hence a better income for farmers, so it should be promoted. However, FAO stressed that by organic farming one could not feed the current mankind, even less the bigger future population. Both data and models showed then that organic farming was far from sufficient. Therefore chemical fertilizers were needed to avoid hunger. Other analysis by many agribusiness executives, agricultural and ecological scientists, and international agriculture experts revealed the opinion that organic farming would not only increase the world's food supply, but might be the only way to eradicate hunger. FAO stressed that fertilizers and other chemical inputs can much increase the production, particularly in Africa where fertilizers are currently used 90% less than in Asia. For example, in Malawi the yield has been boosted using seeds and fertilizers. FAO also calls for using biotechnology, as it can help smallholder farmers to improve their income and food security. Also NEPAD, Development Organization of African Governments, announced that feeding Africans and preventing malnutrition requires fertilizers and enhanced seeds. According to a more recent study in Science Digest, organic pest management practices shows an average yield only 13% less than conventional. In the world's poorer nations where most of the world's hungry live, and where conventional agriculture's expensive inputs are not affordable by the majority of farmers, adopting organic management actually increases yields 93% on average, and could be an important part of increased food security. Capacity building in developing countries. Organic agriculture can contribute to ecologically sustainable, socio-economic development, especially in poorer countries. The application of organic principles enables employment of local resources and therefore cost-effectiveness. Local and international markets for organic products show tremendous growth prospects and offer creative producers and exporters excellent opportunities to improve their income and living conditions. Organic agriculture is knowledge-intensive. Globally, capacity-building efforts are underway, including localized training material, to limited effect. As of 2007, the International Federation of Organic Agriculture Movements hosted more than 170 free manuals and 75 training opportunities online. In 2008 the United Nations Environmental Programme and the United Nations Conference on Trade and Development stated that organic agriculture can be more conducive to food security in Africa than most conventional production systems, and that it is more likely to be sustainable in the long term, and that yields had more than doubled where organic, or near-organic practices had been used, and that soil fertility and drought resistance improved. Organic agriculture and the Millennium Development Goals. The value of organic agriculture in the achievement of the MDGs, particularly in poverty reduction efforts in the face of climate change, can be shown in its contribution to both income and non-income aspects of the MDGs. A series of case studies conducted by the Asian Development Bank Institute in Tokyo showed that OA contributes to both income and non-income aspects of the MDGs in all the study areas in selected Asian countries. OA unregistered trademark S outcomes on MDGs include contributions to the alleviation of poverty by way of higher incomes, improved farmers' health owing to less chemical exposure, integration of sustainable principles into rural development policies, improvement of access to safe water and sanitation, and expansion of global partnership for development. A related ADBI study on OA estimates costs of OA programs and sets them in the context of the costs of attaining the MDGs. The results show considerable variation across the case studies, suggesting that there is no clear structure to the costs of adopting OA. Costs depend on the efficiency with which the OA adoption programs are run. The lowest cost programs were more than 10 times less expensive than the highest cost ones. A further analysis of the gains resulting from OA adoption reveals that the costs per person taken out of poverty was much lower than the estimates of the World Bank, based on income growth in general or based on the detailed costs of meeting some of the more quantifiable MDGs. Externalities. Agriculture imposes negative externalities upon society through land and other resource use, biodiversity loss, erosion, pesticides, nutrient runoff, water usage, subsidy payments and assorted other problems. Positive externalities include self-reliance, entrepreneurship, respect for nature, and air quality. Organic methods reduce some of these costs. In 2000 uncompensated costs for 1996 reached £2,343 million or £208 per hectare. A study of practices in the USA published in 2005 concluded that cropland costs the economy approximately $1 billion, while livestock production costs $714 million. Both studies recommended reducing externalities. The 2000 review included reported pesticide poisonings but did not include speculative chronic health effects of pesticides, and the 2004 review relied on a 1992 estimate of the total impact of pesticides. It has been proposed that organic agriculture can reduce the level of some negative externalities from agriculture. Whether the benefits are private or public depends upon the division of property rights. Several surveys and studies have attempted to examine and compare conventional and organic systems of farming and have found that organic techniques, while not without harm, are less damaging than conventional ones because they reduce levels of biodiversity less than conventional systems do and use less energy and produce less waste when calculated per unit area. A 2003 to 2005 investigation by the Cranfield University for the Department for Environment, Food and Rural Affairs in the UK found that it is difficult to compare the global warming potential, acidification and eutrophication emissions, but organic production often results in increased burdens, from factors such as N-leaching and N2O emissions, even though primary energy use was less for most organic products. N20 is always the largest GWP contributor except in tomatoes. However, organic tomatoes always incur more burdens. Some emissions were lower per area, but organic farming always required 65 to 200% more field area than non-organic farming. The numbers were highest for bread wheat and potatoes. The situation was shown dramatically in a comparison of a modern dairy farm in Wisconsin with one in New Zealand in which the animals grazed extensively. Using total farm emissions per kg milk produced as a parameter, the researchers showed that production of methane from belching was higher in the New Zealand farm, while carbon dioxide production was higher in the Wisconsin farm. Output of nitrous oxide, a gas with an estimated global warming potential 310 times that of carbon dioxide, was also higher in the New Zealand farm. Methane from manure handling was similar in the two types of farm. The explanation for the finding relates to the different diets used on these farms, being based more completely on forage in New Zealand and containing less concentrate than in Wisconsin. Fibrous diets promote a higher proportion of acetate in the gut of ruminant animals, resulting in a higher production of methane that is to be released by belching. When cattle are given a diet containing some concentrates in addition to grass and silage, the pattern of ruminal fermentation alters from acetate to mainly propionate. As a result, methane production is reduced. Kappa al. Compared the environmental impact of U.S. dairy production in 1944 and 2007. They calculated that the carbon a footprint a per billion kg of milk produced in 2007 was 37% that of equivalent milk production in 1944. Environmental impact and emissions. Researchers at Oxford University analyzed 71 peer-reviewed studies and observed that organic products are sometimes worse for the environment. Organic milk, cereals, and pork generated higher greenhouse gas emissions per product than conventional ones, but organic beef and olives had lower emissions in most studies. Usually organic products required less energy, but more land. Nitrogen leaching, nitrous oxide emissions, ammonia emissions, eutrophication potential and acidification potential were higher for organic products, however organic methods had less nutrient losses per unit of field area. Other differences were not significant. The researchers concluded most of the studies that compared biodiversity in organic and conventional farming demonstrated lower environmental impacts from organic farming. The researchers believe that the ideal outcome would be to develop new systems that consider both the environment, including setting land aside for wildlife and sustainable forestry, and the development of ways to produce the highest yields possible using both conventional and organic methods. Proponents of organic farming have claimed that organic agriculture emphasizes closed nutrient cycles, biodiversity, and effective soil management, providing the capacity to mitigate and even reverse the effects of climate change, and that organic agriculture can decrease fossil fuel emissions. Critics of organic farming methods believe that the increased land needed to farm organic food could potentially destroy the rainforests and wipe out many ecosystems. Nutrient leaching. According to the meta-analysis of 71 studies, nitrogen leaching, nitrous oxide emissions, ammonia emissions, Eutrophication potential and acidification potential were higher for organic products, although in one study nitrate leaching was 4.4-5.6 times higher in conventional plots than organic plots. Excess nutrients in lakes, rivers, and groundwater can cause algal blooms, eutrophication, and subsequent dead zones. In addition, nitrates are harmful to aquatic organisms by themselves. Land use. The Oxford meta-analysis of 71 studies proved that organic farming requires 84% more land, mainly due to lack of nutrients but sometimes due to weeds, diseases or pests, lower yielding animals and land required for fertility-building crops. While organic farming does not necessarily save land for wildlife habitats and forestry in all cases, the most modern breakthroughs in organic are addressing these issues with success. Professor Wolfgang Branyard says that organic animal production is not good for the environment, because organic chicken requires doubly as much land as conventional one and organic pork a quarter more. According to a calculation by Hudson Institute, organic beef requires triply as much land. On the other hand, certain organic methods of animal husbandry have been shown to restore desertified, marginal, and/or otherwise unavailable land to agricultural productivity and wildlife. Or by getting both forage and cash crop production from the same fields simultaneously, reduce net land use. In England, organic farming yields 55% of normal yields. While in other regions of the world, organic methods have started producing record yields. Pesticides. Unlike conventional farms, most organic farms largely avoid synthetic pesticides. Some pesticides damage the environment or with direct exposure, human health. Children may be more at risk than adults from direct exposure, as the toxicity of pesticides is frequently different in children and adults. The 5 main pesticides used in organic farming are Bt, pyrethrin, rotenone, copper and sulfur. Fewer than 10% of organic farmers use botanical insecticides on a regular basis, 12% use sulfur, and 7% use copper-based compounds. Reduction and elimination of chemical pesticide use is technically challenging. Organic pesticides often complement other pest control strategies. Ecological concerns primarily focus around pesticide use, as 16% of the world's pesticides are used in the production of cotton. Runoff is one of the most damaging effects of pesticide use. The USDA Natural Resources Conservation Service tracks the environmental effects of water contamination and concluded, the nation's pesticide policies during the last 26 years have succeeded in reducing overall environmental risk, in spite of slight increases in area planted and weight of pesticides applied. Nevertheless, there are still areas of the country where there is no evidence of progress, and areas where risk levels for protection of drinking water, fish, algae and crustaceans remain high. Food quality and safety. The weight of the available scientific evidence has not shown a consistent and significant difference between organic and more conventionally grown food in terms of safety, or nutritional value. In 2009, a review of all the relevant research comparing organic to conventionally grown foods was carried out by the United Kingdom's Food Standards Agency, which concluded no evidence of a difference in content of nutrients and other substances between organically and conventionally produced crops and livestock products was detected for the majority of nutrients assessed in this review, suggesting that organically and conventionally produced crops and livestock products are broadly comparable in their nutrient content. There is no good evidence that increased dietary intake, of the nutrients identified in this review to be present in larger amounts in organically than in conventionally produced crops and livestock products, would be of benefit to individuals consuming a normal varied diet, and it is therefore unlikely that these differences in nutrient content are relevant to consumer health. A 2009 review of potential health effects conducted for the UK Food Standards Agency analysed 11 articles, concluding, because of the limited and highly variable data available, and concerns over the reliability of some reported findings, there is currently no evidence of a health benefit from consuming organic compared to conventionally produced foodstuffs. It should be noted that this conclusion relates to the evidence base currently available on the nutrient content of foodstuffs, which contains limitations in the design and in the comparability of studies. Individual studies have considered a variety of possible impacts, including pesticide residues. Pesticide residues present a second channel for health effects. Comments include, organic fruits and vegetables can be expected to contain fewer agrochemical residues than conventionally grown alternatives. Yet, the significance of this difference is questionable. Nitrate concentrations may be less, but the health impact of nitrates is debated. Lack of data has limited research into the health effects of natural plant pesticides and bacterial pathogens. The higher cost of organic food could inhibit consumption of the recommended 5 servings per day of vegetables and fruits, which improve health and reduce cancer regardless of their source. Soil conservation. Supporters claim that organically managed soil has a higher quality and higher water retention. This may help increase yields for organic farms in drought years. Organic farming can build up soil organic matter better than conventional no-till farming, which suggests long-term yield benefits from organic farming. An 18-year study of organic methods on nutrient-depleted soil concluded that conventional methods were superior for soil fertility and yield for nutrient-depleted soils in cold temperate climates, arguing that much of the benefits from organic farming are derived from imported materials which could not be regarded as self-sustaining. In Dirt, the Erosion of Civilizations, geomorphologist David Montgomery outlines a coming crisis from soil erosion. Agriculture relies on roughly 1 meter of topsoil, and that is being depleted 10 times faster than it is being replaced. No-till farming, which some claim depends upon pesticides, is one way to minimize erosion. However, a recent study by the USDA's Agricultural Research Service has found that manure applications in tilled organic farming are better at building up the soil than no-till. Biodiversity. A wide range of organisms benefit from organic farming, but it is unclear whether organic methods confer greater benefits than conventional integrated agri-environmental programs. Nearly all non-crop, naturally occurring species observed in comparative farmland practice studies show a preference for organic farming both by abundance and diversity. An average of 30% more species inhabit organic farms. Birds, butterflies, soil microbes, beetles, earthworms, spiders, vegetation, and mammals are particularly affected. Lack of herbicides and pesticides improve biodiversity fitness and population density. Many weed species attract beneficial insects that improve soil qualities and forage on weed pests. Soil-bound organisms often benefit because of increased bacteria populations due to natural fertilizers such as manure, while experiencing reduced intake of herbicides and pesticides. Increased biodiversity, especially from beneficial soil microbes and mycorrhizae, have been proposed as an explanation for the high yields experienced by some organic plots, especially in light of the differences seen in a 21-year comparison of organic and control fields. Biodiversity from organic farming provides capital to humans. Species found in organic farms enhance sustainability by reducing human input. Proponents of organic farming. Organic agriculture is a production system that sustains the health of soils, ecosystems and people. It relies on ecological processes, biodiversity and cycles adapted to local conditions, rather than the use of inputs with adverse effects. Organic agriculture combines tradition, innovation and science to benefit the shared environment and promote fair relationships and a good quality of life for all involved. Critical analysis. Norman Borg, Professor Ata Wavers and other critics have contested the notion that organic agricultural systems are more friendly to the environment and more sustainable than conventional farming systems. Borg asserted that organic farming practices can at most feed 4 billion people, after expanding cropland dramatically and destroying ecosystems in the process. Borg and his co-authors advocated using organic matter in addition to inorganic fertilizers in soil fertility management, but opposed advocating only organic agriculture for the developing world. The Danish Environmental Protection Agency estimated that phasing out all pesticides would result in an overall yield reduction of about 25%. Environmental and health effects were assumed but hard to assess. One study claims that organic agriculture could feed the entire global population, somewhat more than 6 billion people. It states that organic farms have lower yields than their conventional counterparts in developed countries but higher than their low-intensity counterparts in developing countries, attributing this to lower adoption of fertilizers and pesticides in the developing world compared to the intensive farming of the developed world. However, concerns have been expressed about that study's selection, characterization and interpretation of data, and its assumptions and analytical methods, casting doubt on several of its conclusions. The Centers for Disease Control repudiated a claim by Dennis Avery of the Hudson Institute, that the risk of E. coli infection was 8 times higher when eating organic food. Avery had included problems stemming from non-organic unpasteurized juice in his calculations. Epidemiologists traced the 2011 E. coli 0104 H4 outbreak, which caused over 3,900 cases and 52 deaths, to an organic farm in Bayern 1 quarter TTEL in Germany. A long-term field study comparing organic conventional agriculture carried out over 21 years in Switzerland concluded that crop yields of the organic systems averaged over 21 experimental years at 80% of the conventional ones. The fertilizer input, however, was €34.51% lower, indicating an efficient production. The organic farming systems use €20.56% less energy to produce a crop unit, and per land area this difference was €36.53%. In spite of the considerably lower pesticide input, the quality of organic products was hardly discernible from conventional analytically and even came off better in food preference trials and picture-creating methods. Urs Nigli, director of the FIBL Institute, contends that a global campaign against organic farming derives mostly from Alex Avery's book The Truth About Organic Farming. See also. References. Further reading, Aberman, M. From the Good Earth, A Celebration of Growing Food Around the World. HNA Books. ISBN A0-8109-2517-6. Avery, A. The Truth About Organic Foods. Henderson Communications, LLC 2006. ISBN 0-9788952-0-7, Committee on the Role of Alternative Farming Methods in Modern Production Agriculture, National Research Council 1989. Alternative Agriculture. National Academies Press. Guthman, J. Agrarian Dreams, The Paradox of Organic Farming in California, Berkeley and London, University of California Press. 2004. ISBN 978-0-520-24094-0, Lampkin, N. and S. Paddle. The Economics of Organic Farming, An International Perspective. Guilford, CAB International 1994. ISBN 0-85198-911-X, OECD. Organic Agriculture, Sustainability, Markets, and Policies. CABI International 2003. Free full text. Beecher, N.A., A.L. Agroecology of Birds in Organic and Non-Organic Farmland. Conservation Biology 16, 6, 1621 €30. Brown, R.W. Margin Field Interfaces and Small Mammals. Aspects of Applied Biology 54, 203 €210. Emsley, J. Going One Better Than Nature. Nature 410, 633 €634 doi, 10.1038/35070632. Gabriel, D. and Teats Chant. Insect-pollinated plants benefit from organic farming. Agriculture, Ecosystems and Environment 118, 43-48. Quepper, G. and L. Jenner. Organic Crop Production Overview, a Euro-National Sustainable Agriculture Information Service. August, 2004. Paul, J. The Farmer's Organism, The Foundational Idea of Organic Agriculture. Journal of Biodynamics Tasmania 83, 14 €18. Markandia, A. and S. Setboon San 2008. Organic Crops or Energy Crops? Options for Rural Development in Cambodia and the Lao People's Democratic Republic. ADB Institute Research Policy Brief 29. ADBI, Tokyo. Smil, V. Enriching the Earth, Fritz Haber, Karl Bosch, and the Transformation of World Food. MIT Press. ISBN A0-262-19449 Exa, Wheeler, S.A., What Influences Agricultural Professionals' Views Towards Organic Agriculture? Ecological Economics 65, 145 €154 doi, 10.1016/J. Ecolecon. 2007.05.014, Wickramasinghe LP, Albat Activity and Species Richness on Organic and Conventional Farms, Impact of Agricultural Intensification. Journal of Applied Ecology 40, 6, 984 €93. External links, Organic Farming at DMOZ, Quepa, G.A. Brief Overview of the History and Philosophy of Organic Agriculture. Kerr Center for Sustainable Agriculture. 2010. Organic Prints. A database of research in organic food and farming. Organic Farming. Agriculture and Rural Development, European Commission. Organic Agriculture Programme. Food and Agriculture Organization, United Nations. Organic Production and Organic Food, Information Access Tools. Alternative Farming Systems Information Center. National Agricultural Library, USDA. Organic Agriculture. E-Organic Community of Practice with Extension, America's Land Grant University System and Partners. Organic Farming Can Feed the World, UM Study Shows. University of Michigan News Service. July 10, 2007.